Hello. So we are going to cover the final chapter of today's book, which is electricity. So, here are a few questions that I want you to think about before you continue watching the video. First of all, have you ever seen anything that requires electricity? And second of all, do you know any of the items that have been listed in this image? For example, maybe number four or number one. All right. So, so if you do not have any questions, then we shall continue. So, conductors and insulators. Simply, before I would like to tell you what they are, would you like, would anybody or do you have an explanation in your own words what conduction and what is a conductor and what is an insulator? All right. So, if you have anything along the lines of a conductor being something that allows electricity to pass through easily, and insulators being the opposite of that, then you are correct. Simply, conductors conduct electricity, which means that they can transport electricity. However, the opposite of that is an insulator, which does not and actually blocks the movement of electricity, which is sometimes a very important thing. So now, you could also try an experiment with this as well. For example, for example, for example, the reason why we have these the reason why we have some insulators here is to keep us safe. Now, can anybody tell me why you should not touch any of these wires because when it's complete? Can anybody provide me a simple explanation? Just think about it. Yes, you could be saying that it could electrically shock you, which is correct. If not handled properly, you might get shocked. Now, now we also have another question, which is, does water conduct electricity? And well, yes. Well, to answer this question, first of all, water is usually not pure. However, that does not mean that we have pure that water. That means because not all water is pure. And usually distilled water is the water that does not conduct electricity. The one that's more electrically conducting would probably be salt water, since salt is an extremely highly conductive material. Um, yeah. So, continuing on, we will explore the uses of conductors and wait, no, apologies. So, if you want to try this at home, you could try to light up the you could try to light up a light by putting some distilled water into a beaker, and then you put aluminum foils. So in distilled water, it will not really work that much. Will not work because the main reason here is water isn't electrically conductive on its own, but it will be extremely conductive because of the materials that are added in water. So after you add teaspoons of salt into that water, then the water would start being very conductive, and it would cause the lamps to light up. So it's really just a matter of what's in the water and not whether water is conductive, because some water is not conductive while some forms of water are not as conductive as others. So just remember that because you may need this in a later lesson. Not what you may have to learn about this in future lessons about different electricity and conduction, etc. So yeah. Now let's continue on. So so therefore, if you have done this test under your parents' discretion, well now try to explain as to why this works, and try to theorize whether if this experiment works on your body. So, for example, if I were to hold two ends of a wire, do you think that I will turn that light bulb on, or do you think that the body will not be able to do so following this experiment? Also, while doing this experiment, please do not, please be careful. I want to remind this many, many times because it's an extremely dangerous thing to do without the parent's discretion. In addition, can, in addition, because of what we have just discussed, what will happen if something were to, if we had a thunderstorm and lightning? As I've said, it's what's in the water that causes it to be conductive, and not it's not what if the water is conductive. So yeah, have a think, and then try to form an answer as to why parents always warn you against this problem. Now, continuing on, using electrical conductors and insulators in electrical appliances. So, as we have discussed before, we have seen a ton of safety measures being added into electrical systems, from plastic in our machines to basically just everything else that is made out of this material, and anything else that's made of electricity. All of it has a form of insulation. And can anybody tell me why we have this form of insulation? What happens if we do not have this insulation? What do you think would happen? Have a think before continuing on this video. All right, assuming that you have thought of it and you may have assumed the answer that, well, if some of these appliances did not have any insulation, then it would absolutely hurt you in many ways that you do not want to happen. For example, if you use a laptop or an ironing thing on an iron without the insulation, the iron would probably burn your hands, and the laptop would probably also burn your hands, depending on depending on which how do we say this? Depending on, it's gonna burn in your hand, but it's not going to be as dangerous, and it's also going to be very fragile. Now, conductors, insulators, and mains of electricity. We have discussed about conductors and insulators in the beginning of this class. So we know that conductors are used to make the electricity work. But why do we need insulators, you may ask? Well, as we have already discussed before, it is very important because it helps us not to get shocks or become warm. So now, yes, some of these things may use only a few volts. However, with alternating current, we use hundreds or even thousands of volts, and this is very dangerous for you. However, we need to understand that this amount of volts changes for each country. So, for example, one country, for example, might be the U.S., might have around, like, if I were to remember correctly, 100 volts, while the EU has a higher amount of volts. So make sure to check, because if you put a 110 volt charger into a 200 volts, it might explode. And the other way around could happen, but instead of explode, it would work slower. So now, we know that a lot of metals, copper, iron, etc., are very, very good conductors. The reason why copper is used as a conductor instead of other metals which are more conductive is because of its price. These are good conductors, and these allow for it to pass. Therefore, electricity safety should be reminded that, please do not ever touch broken wires like this. If you see that, do not try to touch it because it might shock you. In addition, do not pull out plugs the way that this guy is doing it right now, because it will slowly wear down the plug, and it will be either one, very unusable and very unreliable, or two, you would get shocked every time you touch it. So please do not ever do this, and instead grip the plug, because it is designed to be gripped. It is designed to be taken by the grip and not taken by the actual wire. Only take it from a wire when you really, really need it, or in some emergency situation. Other than that, do not, because it will hurt you in the future. So now, switches. You have definitely seen a light switch. You definitely have seen a light switch. If you haven't, I don't know what to say about you, because it's kind of basic. Well, what do switches do? Can anybody think about it? What do switches do? Now, I have given you enough time because you probably have slowed down the video to think about it. But yeah, as you see, switches, well, they turn things on and off. In a circuit, a switch is simply something that that continues or stops the current. For example, you can make a switch basically anything. You don't need to make the switch the type of switches you see in your home. You could use this as a switch. So, the way to identify if a switch is on or off is like a model like the one shown in the image here is to see if both of these are connected. If both of these set things are connected, then well, you probably have a switch that is on. So now, switches are really, really simple because they don't really have much things to talk about. I don't really have any true stuff to talk about switches. But if you want to know a bit more about switches, you might want to research about it on Google and maybe also learn more about electrical currents because this is very simplified. You can use multiple switches at once. You could totally do that. And if you use multiple switches at once, then what will happen is that you need to turn on all of the set switches before you can actually use your item. Now, why do we use a metal paper clip to make the switch? You may think about it for real quick, and I'll give you a hint: metal. Second of all, why do you think the base is made of wood? Is there any true reason why you think it should be made of wood instead of something else? Maybe like, I don't know, perhaps maybe you could make it out of metal. You could make it out of all the other things, something else type stuff. So yeah, there's more than just just wood that you can make. But why is it wood? Now, changing the number of components in the circuit. So, batteries. So, so a battery is basically chemical energy trapped in a box. Basically, it's trapped in a container. Simply put, it is just a box trapped in a container. It's just some chemicals that have energy that are trapped. So, a car battery has 12 volts, and this car battery is used to provide energy to everything. So, if you want to try, you could try to, if you want to do this, you could try to connect multiple batteries and see if many lights shine brighter if you connect with multiple batteries. If you want a spoiler alert, you won't because you should test it yourself. But yeah, if you try to add more components or less components and light bulbs, maybe light the batteries or maybe the switches, you should try it out. And you should also try to research more about circuits and learn about parallel and parallel forms of and also many forms of conduction of electricity such as parallel, etc. and etc. There will be a lot of tutorials about it if you just search it on YouTube or Google. So yeah, hope you have a great day. See you.